Hello everyone, welcome to class. So we're starting a new topic today, electric current 1. In your lesson notes, I gave you some definitions of some components. I want to demonstrate that here. Now in the previous lesson, electrostatics, it was a study of electrons, stationary electrons, but this is electricity, is the study of charges in motion. Okay, by the end of the lesson, I have a podcast for you too on the differences between electrostatics and electricity. Okay, so this, for the sake of time, I've already built this circuit, but it's pretty easy to build. I'm using FET simulation. Okay, so it's really pretty easy for you to build. So let me just quickly demo. This is your wire. All right, you can add your battery, roll it however you want, bulb, resistor. Okay, these are the components. You can use pretty much anything you want here to test the resistance of anything. There's pencil. So, but just for the sake of time, I've done it ahead of time so that we can just move on to explanation straight on. All right, so onward. All right, so this is a simple circuit, like I told you. Um, the components of a circuit, you need to have a power source, the battery, which is this. I've highlighted the value so that you also see them. This battery has a voltage of 32. Okay, then the next thing is that you need a conductor. Here the wires are the conductor. You remember a conductor is that thing that allows free flow of electricity in it. So this wire is serving as a conductor. Then you need the load. The bulb here is the load. Then you need a switch to open and close the circuit. I also have connected a resistor here. Okay, so that we can use it and see how this works. So when I close the circuit now, you see the movement of the flow of electrons. That tells you that electricity is flowing. Now, I've for the sake of this experiment, I've also set the internal resistors of the voltage and the light bulb to 0 so that they just make it very simple. So understand the concept in a very simple way before we start building on it. Okay, so this is a simple circuit has been closed. An ammeter from your lesson notes is that instrument that is used to measure the current flowing in a circuit. It's usually connected in series. So this is an ammeter here. We can use that to measure, say, current. We can use that to measure the current flowing in the circuit. An ammeter is connected in series. This is a series connection. What you're looking at here is a series connection. A parallel connection is that you have to connect across, you know, a it comes here and then split, but this is a series connection anyway. So let's start demonstrating the first demonstration. Let's measure the electricity flowing in this circuit. So like I said, you connect it in series. This is 3.2. Then of course you remember the Ohm's law, V equals IR. You can use it. This is your voltage, this is your resistor, and then this is the load. So we're measuring the current. This tells us that the current is 3.2. So the current in this circuit is 3.2. Now let's see what happens if I increase the voltage. Okay, let's see what happens. Now if I okay, let me reduce the voltage first. Now you remember I'd given you these definitions before. You have independent variable and dependent variable. Independent variable is the one that the scientist is the one changing. The- Then the dependent variables, these are the variable that is dependent on the independent one for their values. So when I change the value of this voltmeter, so sorry, this battery, so this is now obviously my independent variable because I'm the one changing it. Now we're going to see the effect it's going to have on the current in the circuit. The current in the circuit is a dependent variable because whatever happens here, we are looking at what happens to the current, right? And of course, you remember that in any experiment, you change one thing at a time and measure the behavior in your experiment. So I'm going to alter the value of the voltmeter of the battery, and then we'll see what happens. I'll start from 5. Okay, you will also watch the flow of the current as I go too close to zero. Now, if I make it zero, no current is flowing. Now, by the time I start increasing it, also watch the ammeter. Let's see what happens to that too. You can see what's happening. Okay, you can see what's happening. That there's an increase. All right. Okay, so that's for this. Then a voltmeter is used to measure the voltage potential difference in circuits. It's usually connected in parallel. Now the voltmeter here, if I taking out the values for it, if I say okay, don't let's take out the values and we didn't know what was the value here, you can just simply put your probe here and here and it will tell you. See, it gives you the reading, but it must be connected in parallel. So at every point, it gives you the figure. Okay, so a voltmeter is used to measure the amount of voltage in a circuit, while an ammeter is used to measure the amount of current in a circuit. A voltmeter is connected in parallel, while an ammeter is connected in series in a circuit. So take note of this. One final thing, what you're seeing is the flow of electron in the circuit. But the flow of conventional electricity is in the opposite direction of the flow of electrons. Now let me show you that. You see, it's actually in the opposite direction. So let's quickly show you that. Okay, so we'll get to the next simulation.